as we continue on with the issue of rationalizing the denominator, we want to think about the situation in which I have something like 1 divided by 2 plus the square root of 3. So my issue with this is no radicals appear in the denominator. The denominator isn't just a radical, but there is a radical in the denominator. To get rid of this, I'm going to need to look at conjugates. Conjugates are basically, the basic conjugate is that the conjugate of a plus the square root of b is a minus the square root of b. The reason that we care about conjugates is that they do some neat things for us. If I take two conjugates and multiply them by each other, in this case I have an irrational number, when I multiply them out, a plus b times a minus b, or in this case a plus the square root of b times a minus the square root of b, the rational or the radical goes away. So I need to think about what is the conjugate of my denominator. Because I don't want a radical in the denominator, I need to think about what should I multiply this by to get rid of that radical. So the conjugate of a plus the square root of b is a minus the square root of b. So the conjugate will be 2 minus the square root of 3. And you have to remember we need to multiply by a convenient value of 1. So I need to multiply the numerator by 2 minus the square root of 3. Both of these have to be the same. My multiplication in the numerator is straightforward. I have 1 times this, which is 2 minus the square root of 3. And in the denominator, I have to FOIL this out. So my first term becomes 2 times 2, which is 4. My outside term is minus 2 root 3. My inside term is plus 2 root 3. And my last term is minus the square root of 3 times the square root of 3. Minus 2 root 3 plus 2 root 3 are going to cancel out. So my numerator is 2 minus root 3. My denominator is 4. Square root of 3 times square root of 3 ends up just being 3. So this is 4 minus 3. 4 minus 3 is 1. So this is 2 minus the square root of 3 all over 1, which I can simplify to 2 minus the square root of 3. So I was able to use conjugates to work through this problem. The math won't always be quite so pretty, but I can use the same thought process. So if I'm looking at 1 plus the square root of 2 divided by the square root of 2 minus the square root of 3, I just need to figure out what is the conjugate of the denominator. We're always looking for the conjugate of the denominator because we don't want radicals down here. So the conjugate, I just changed the sign in the middle, so this should be the square root of 2 plus the square root of 3. And remember, I'm always multiplying by a convenient value of 1. So this should be the square root of 2 plus the square root of 3 in the numerator here, just like the denominator. Now, this problem is a little trickier because I have to FOIL the numerator and the denominator. So foiling the numerator, I'm going to go kind of quickly. First term is 1 times the square root of 2. Outside is 1 times the square root of 3. Inside is the square root of 2 times the square root of 2. And last is the square root of 2 times the square root of 3. In the denominator, my first term is the square root of 2 times the square root of 2. My outside is the square root of 2 times the square root of 3. My inside is minus the square root of 2 times the square root of 3. And my last is minus the square root of 3 times the square root of 3. Okay, so looking at my numerator as I work through this, the square root of 2 stays as the square root of 2. And the square root of 3 stays as the square root of 3. But root 2 times root 2 is just going to be positive 2. And the square root of 2 times the square root of 3, those can go under the same square root and become the square root of 6. This numerator is fully simplified. I can't combine any of those terms any further. But now when I look at my denominator, square root of 2 times square root of 2 is positive 2. Root 2 times root 3 is the square root of 6. Root 2 times root 3 is the square root of 6. So I've got plus square root of 6 minus square root of 6. Root 3 times root 3 is going to give me 3. So these two terms, the inside and outside terms in the denominator, cancel out. And I get 2 minus 3. Well, 2 minus 3 is negative 1. So this is just root 2 plus root 3 plus 2 plus root 6 all over negative 1, or I can distribute that negative in, giving me negative root 2 minus root 3 plus, that should be minus 2 minus root 6. So there is my final simplified answer. When we're talking about conjugates, we not only have conjugates for radicals, but we have conjugates for one set of rational exponents. The square root of b can be rewritten as b to the 1/2. So I can have a similar, so I can translate from square roots into rational exponents. Now you have to be careful because this rule of conjugates for rational exponents is only good when our rational exponent is b to the 1/2 or a variable to the 1/2. It doesn't work if we have anything other than a rational exponent of 1/2. But let's look at how this works out in a problem. So here I have x to the 1/2 minus 2 divided by 3 times x to the 1/2 plus 2. You want to be careful here because only x is being raised to the 1/2, not 3. There would need to be parentheses around the 3x if the 3 was being raised to the 1/2. So I need to think about what's the conjugate. And our pattern for conjugates is you change the sign. So this should be 3x to the 1/2 minus 2. And remember, convenient value of 1, our numerator should be 3x to the 1/2 minus 2. I need parentheses because I am going to be foiling. All right, so foiling out my numerator. So my first term gives me 3x to the 1/2 squared because I have x to the 1/2 times x to the 1/2. My outside term gives me minus 2x to the 1/2. My inside term gives me minus 6x to the 1/2. And my last term gives me plus 4. In the denominator, if I FOIL, I get 9x to the 1/2 squared minus 6x to the 1/2 plus 6x to the 1/2 minus 4. If we look in the denominator, minus 6x to the 1/2 plus 6x to the 1/2, those are going to cancel out. So let's look at my numerator again. So x to the 1/2 squared is going to be x. So this is 3x. These two terms here are both x to the 1/2, so I can combine them. They have the same base, they have the same radical or rational exponent. So I've got minus 2 minus 6. This is minus 8x to the 1/2 plus 4. In the denominator, x to the 1/2 squared is x, so this is 9x. My x to the 1/2 terms cancel out, and I get 9x minus 4. This is a fully simplified, There are no radicals in the denominator, and there's no factors with rational exponents that can be reduced any further.